What if I told you that the most destructive objects in the universe might also be doorways? That somewhere deep inside a black hole, past the point of no return, there could be a tunnel leading to another time, another place, or even an entirely different universe? For over a century, this question has haunted physicists, inspired science fiction, and split the scientific community right down the middle. Today, we're going to separate the hard science from the speculation and find out what black holes could really be hiding. Welcome back to the channel. If you're fascinated by the universe and the strange physics that holds it together, you're in exactly the right place. Stick around to the end, because the final theory we'll cover is one that might just change how you see your own existence. Let's get into it. Before we can talk about gateways, we need to understand what a black hole actually is. When a giant star, many times the mass of our sun, runs out of fuel, it can no longer hold itself up against its own gravity. It collapses. The outer layers explode outward in a supernova, but the core caves in on itself, crushing an enormous amount of mass into an unimaginably small space. The result is a region where gravity becomes so intense that nothing, not even light, can escape. That's why it's black. The boundary around it is called the event horizon. Cross it, and there is no coming back. It's not a wall or a surface. It's simply the point where the escape velocity exceeds the speed of light. And here's the truly mind-bending part. At the very center, our equations predict something called a singularity, a point of infinite density where the laws of physics, as we know them, completely break down. And it's precisely because physics breaks down there that the door is left open for some extraordinary possibilities. Which brings us to one of the most famous ideas in all of physics, the wormhole. In 1935, Albert Einstein and his colleague Nathan Rosen were studying the mathematics of his theory of general relativity. They discovered that the equations describing a black hole could, in theory, be extended to form a kind of bridge, a tunnel connecting two separate points in spacetime. We now call this an Einstein-Rosen bridge, or more popularly, a wormhole. Picture the fabric of space as a sheet of paper. Normally, to get from one side to the other, you travel across the surface. But if you fold the paper and punch a hole through it, you create a shortcut. A wormhole, in theory, does exactly that. It could link two distant regions of our universe, or potentially two completely different universes altogether. It's a beautiful idea, and it comes straight out of Einstein's own mathematics. But, and this is a big but, a mathematical solution on paper doesn't guarantee something exists in reality. And as physicists looked closer, they ran into some serious problems. Problem number 1, survival. As you fall toward a black hole, the gravitational pull on your feet would be vastly stronger than the pull on your head. The difference is so extreme that you'd be stretched out like a piece of spaghetti, which is why scientists genuinely call this process spaghettification. For a typical black hole, you'd be torn apart long before you ever reach the center. Problem number 2, stability. The original Einstein-Rosen bridge is mathematically unstable. It would snap shut so quickly that not even a beam of light could pass through before it collapsed. In other words, the natural wormhole is a door that slams shut the instant it opens. To keep one open, you'd need something theoretical called exotic matter, a substance with negative energy that pushes outward instead of pulling in. The trouble is, we've never confirmed that exotic matter exists in the quantities required. There's a fascinating clue, though, in something called the Casimir effect, which shows that negative energy is at least possible on tiny scales. But scaling that up to hold open a wormhole, that remains pure science fiction, for now. But if black holes are objects that nothing can escape, then logic asks an obvious question. Could there be something that's the exact opposite? Enter the white hole. A white hole is a theoretical region that nothing can enter, but from which matter and light constantly pour out. If a black hole is the entrance to a wormhole, then a white hole could, in principle, be the exit, perhaps blasting that swallowed material out into another universe entirely. Here's an interesting fact to chew on. White holes are not forbidden by general relativity. The mathematics allows them, but we have never observed one, and many physicists believe they may be impossible to form in the real universe because they appear to violate the laws of thermodynamics. So while the white hole completes the elegant picture of a cosmic gateway, It remains one of the most speculative objects in all of physics. Now for the theory I promised you at the start, and it's a big one. Some physicists have proposed that on the other side of a black hole's singularity, the collapsing matter doesn't simply vanish. Instead, it could bounce, expanding outward to create a brand new universe, a baby universe, completely sealed off from our own. The physicist Lee Smolin took this even further with an idea called cosmological natural selection. He suggested that universes which are good at producing black holes would, in turn, produce more universes, meaning our cosmos might be fine-tuned not for life, but for making black holes. Each black hole, a seed for a new reality. And then there's an idea from physicist Nikodem Popławski, who proposed that every black hole might contain a separate universe, which leads to a staggering thought. If that's true, then our entire universe, everything you've ever known, could itself be sitting inside a black hole within some larger parent universe. Let that sink in for a moment. So let's ground ourselves. What do we actually know? We know black holes are real. In 2019, the Event Horizon Telescope captured the first ever image of one, and in 2022, we photographed the supermassive black hole at the heart of our own galaxy. We've detected gravitational waves from black holes colliding. These objects are no longer theory. They're observed fact. But the gateways, the wormholes, the baby universes, those remain unproven. They live in the gap between what our equations permit and what nature actually does, a gap that physics has not yet closed. So, are black holes gateways to other universes? The honest answer is, we don't know yet. The mathematics of Einstein's relativity leaves the door tantalizingly open. Wormholes, white holes, and entire universes are all permitted on paper. But every one of them faces enormous obstacles, from unstable tunnels to exotic matter we've never found. What's certain is that black holes are far stranger than fiction, sitting right at the edge of human understanding. And it's precisely at that edge, where the equations break down, that the greatest discoveries of the next century may be waiting. If this video expanded your mind even a little, do me a quick favor, hit that like button, because it genuinely helps the channel reach more curious people just like you. Share it with a friend who loves a good cosmic mystery. And if you're not already subscribed, tap that button and ring the bell so you never miss what we explore next. Until then, keep looking up. The universe has plenty more secrets, and we're only just getting started.